Extrema on the interval. Extrema are extreme values. So we call them maximum or minimums. Maximum or minimums. Okay? So there's two types of maximum and minimums, though. There's an absolute maximum and minimum, and there's what we call relative or local maximum minimums. Okay? So the difference, what is the difference between them? Well, the difference between them is, you can see. Let me highlight them. So the orange, actually, you know what? Let me choose a different color. The green dot I just made right here. That is both an absolute and relative extrema. So what does it mean by absolute? Absolute means the absolute highest point is an absolute maximum. So that's an absolute maximum. This is an absolute minimum because it's the absolute lowest point from A to E. From A to E, right? This interval goes from A to E. So from A to E, the absolute lowest point is at A. And the absolute highest point is at E. Okay, those are absolute. So absolute means highest and lowest. Relative. Well, you can see relative. Relative's at B and C. So at B, it is a peak, right? It is a peak, but it's not the highest peak overall, right? So anything that peaks, anything that changes direction, if it changes direction from negative to positive or positive to negative, so this is, so from A, it goes up, right? Increasing, 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 and then at B, it changes, right? When it changes, it creates a maximum. This maximum happens to be relative because it's not the highest. This guy is the highest, okay? And then at C, you change from decreasing to increasing. That creates a minimum, but it's not the absolute minimum because A is. So relative maximum and minimums are just, for that area, the low point. It's a low point, but not necessarily overall, right? Not necessarily overall. So today what we're going to do is we're going to find those guys. They're going to give us a function, and they're going to say from this interval to this interval, find me all of these guys. Find me all of the absolutes, maximum or minimums. Find me all of the relative maximum minimums. We're not going to have a picture to look at either. We're going to have to do it a different way. How are we going to do it? Well, we're going to do it using first derivative test. Okay? So, a couple of important things to know. A function. So all of the ones we're going to look at today, we're not looking at any implicit. We're just implicit. We're looking at all functions today. So we're going back to explicit. A function may have both a maximum and minimum over an interval, just like this guy. This guy is a function, and it has a relative maximum, a relative minimum, an absolute maximum, and an absolute minimum. Okay? Only a maximum. So sometimes they'll only have maximums. Sometimes there won't be any minimums. Or the opposite, only a minimum. Or it could have neither. Neither maximum or minimums. Okay? I highlighted in orange here, but I know it didn't come up in orange on yours. But the reason I did is because this is one of the things we're going to be doing for a long time, finding critical values. So what are critical values? Critical values are values of x where the derivative is equal to 0. So wherever the derivative is equal to 0. So when I say the derivative is equal to 0, what does that mean in terms of slope? If I say a derivative is equal to 0, what does that mean? The derivative is this, right? Let's go back and look at the pictures here. Is there any spot where the derivative is horizontal? Like the derivative here. Is the derivative positive, negative, or 0? Because it's going uphill, right? And then the derivative over here is negative, right? Well, to go from positive to negative, what did I have to do to go from positive to negative? Go to 0, right? Right there. There's another one right there. There's another one right there. Anywhere the derivative is 0 is what we call a critical value. So this guy's got a lot of critical values. Okay? So wherever the derivative equals 0, aka a horizontal tangent line, or it doesn't exist. So anywhere the function changed from increasing to decreasing, or the opposite, from decreasing to increasing. Anywhere it changed direction. Okay? Increasing means going uphill, right? Decreasing means going downhill. So if it changes direction, it creates what's called a critical value. Okay? So this is how we write it. Critical values, critical points. Okay? Critical points are x values. X values. While maximum and minimums are y values. So when we're talking about critical points or critical values, critical numbers, we're talking about the x. But when we're talking about maximum or minimums, we're talking about the y. So in other words, if the point 2, 70 is a relative minimum, the minimum of the function is 70, and it occurs at x equals 2. X equals 2. Okay? All right. So that leads us to, how do we do this? Well, it's called the first derivative test because we're going to use the first derivative. What is it? What does the first derivative test tell us? It tells us where a function is increasing and where it is decreasing. Okay? Thanks. So it tells us where a function is increasing and where a function is decreasing. Okay? Okay? So if we know where it's increasing and we know where it's decreasing, wherever it changes direction has to be a critical value. Okay? So that's what this says pretty much. It says if f prime is positive, greater than 0, function's increasing. Because the only way for it to increase is if the slope of the tangent line is positive. If it's negative, it's decreasing. If it's 0, it's doing something like B, C, D. It's not going up or down. It's kind of constant. Okay? So that's what we're doing today. That's exactly what we're doing today and probably tomorrow too, because we're not going to finish today. Okay? Where is it increasing? Where is it decreasing? All right. Where is the function increasing? Where is the function decreasing? So let's look at example number 1. Go to the backside. So I don't get a picture. They don't tell me a picture. So I don't have a picture like I did earlier. So I have to kind of, not draw a picture, but I have to kind of see what's going on. So for this guy, I have to find the critical numbers. The critical numbers are right here. Where is it equal to, where is the derivative equal to 0? Okay. And then I have to use that to figure out where is the function increasing and where it is decreasing. And then at those spots, that's where relative maximum and minimums will be. Okay, so the first thing we're going to do is find the critical numbers. So critical numbers are when the derivative equals 0. So the first thing we got to do is find the derivative. So the derivative of f of x is 3x squared minus 12x. We're going to figure out where that equals 0. So how do I do that? Set it equal to 0. Solve for x. Well, it's a binomial. It's got a GCF. The GCF is 3x. Zero product property says set them both equal to 0. 3x equals 0. X minus 4 equals 0. Solve for x. I'm going to get two answers. X equals 0. And x equals positive 4. Those are my critical numbers or critical values. Sometimes they're called critical numbers. Sometimes they're called critical values. Whatever you call them. Zero and 4. Okay? So I found the critical numbers. Now I'm going to use those to figure out where it's increasing and where the function is increasing and decreasing. So at critical values, f is constant. It's not increasing, it's not decreasing. So that means this guy here, f of x, is not increasing or is not decreasing at 0 and 4. So it's not going uphill, it's not going downhill, it's kind of a holding pattern. It's going horizontal at 0 and 4. Okay, so now what I'm going to do is I'm going to draw a number line. I'm going to draw a number line. This is the first derivative test. What am I going to put on the number line? Any critical number that I found. So I found 2. I found 0, and I found positive 4. So this is the first derivative test that I'm doing here. What I'm going to do is I'm going to plug in numbers in between. So I know at 0 and at 4, the derivative is 0. But what about in between 0 and 4? What about in between 0 and 4? And what about greater than 4? And what about less than 0? Anywhere there, anywhere except 0 and 4, it has the function has to be either increasing or decreasing. So I need to figure out what. So from 0 to 4, it's either increasing or decreasing. How do I figure out if it's increasing or decreasing? I'm going to use the first derivative test. The first derivative test said if your derivative is positive, it's increasing. If your derivative is negative, it's decreasing. So I'm going to pick a number in between 0 and 4. Doesn't matter which number. Doesn't matter which number you can. Whole number, decimal, fraction, doesn't matter. Because it's going to be doing the same thing from 0 to 4. It's not going to change. I would suggest picking the easiest value you can. So probably 1. I'm plugging it into the derivative. Derivative, because it's the first derivative test. That's why it's called the first derivative test. So I plug it into the derivative. This is the only time I plug things into the derivative. So the derivative was 3x squared minus 12x. All I care about is it a positive number or is it a negative number? I could care less what the number is. I just need to know if it's greater than 0 or less than 0. Okay. Yeah, it's looking like it's going to be less than 0. So 3 minus 12 is negative 9. So what that means is everywhere between 0 and 4, I'm going to get a negative derivative. I'm going to get a negative derivative. That's why I draw negative signs in there. Negative derivative. So if it has a negative derivative, what does that mean it's doing? Decreasing. Decreasing. Good. So it's decreasing from 0 to 4. Okay. Now we got to choose a number bigger than 4. Anything. Could literally be any number bigger than 4. Again, choose something that's not hard. Choose something that's easy, like 5 or 6 or 10, something like that, because we have to plug it back in. So I'm going to choose 5 because it's bigger than 4. Is that the only number I could have chosen? No. But I'm just trying to choose things that are small, especially because I have to square them. So I'm plugging it into the derivative. So I have 3 times 25 minus 60. So 75 minus 60 equals positive 15. Again, I could care less what number it is. I just want to know if it's positive or negative. In this case, it's going to be positive. So that means after 4, derivative is positive. So if derivative is positive after 4, that means the function is increasing. Good. One more thing to check. Less than 0. -1, -2, -3, -10. Any of those numbers we have to plug in. So I'm going to choose -1. So 3, -1 squared minus 12 times -1. So I get 3 plus 12. Positive number again. So that means everywhere before 0, less than 0, the function was increasing. Between 0 and 4, the function was decreasing. After 4, it's increasing. So the function, if I were to graph it, it would look like this. Increasing, it would look like this. Increasing gets to 0, decreasing gets to 4, increasing. Okay? Okay. So now that I know that, I have to write where is it increasing and where is it decreasing. So let me draw that here. Increasing. So where was it increasing? From where to where? Yeah, so the first one is negative infinity to 0. Or it picks back up at 4 and continues on forever, right? Decreasing. Or increasing, sorry. Now decreasing. The only place it was decreasing is from 0 to 4, in between 0 and 4. So from 0 to 4. So I found my critical numbers, 0 and 4. Found where it was increasing or decreasing. Last thing is find relative extrema. Where are the maximum and minimums? Well, we kind of already did that. Where are we going to have a peak or a valley? 0. 0 is 1, right? Is 0 going to be a maximum or a minimum? Maximum, because what was it doing before 0? And then after 0, that creates a peak, right? And then at 4, what do we have? Minimum, because it was decreasing before and increasing afterwards. Okay, so we're going to write that down. So we'll say relative maximum at x equals 0. Relative minimum at x equals 4. Relative maximum at x equals 0. Relative minimum at x equals 4. We're done. Got everything. That's essentially what we're going to do for all of these. That's what the first derivative test is. The difference between each of these problems is this is a polynomial. Sometimes they'll give you logs. Sometimes they'll give you exponentials. Sometimes they'll give you trig. The equations will change. Okay? That's the only difference. Steps are always going to be the same. When you're trying to find critical numbers, increasing, decreasing, relative maximums, this is what you do. Okay? All right, let's look at example number 2 now. So this one's we don't have to find as much stuff. We just have to figure out where the relative minima are. Minima is the plural of minimum. So if sometimes there might be more than one minimum. We only had one on the last one maximum and one minimum. But sometimes you'll have more than one maximum or more than one minimum. So that's why they said minima. So what I have to figure out for this guy is this guy right here. Where is the relative minimum? Well, to do that, I have to do the first derivative test, right? I have to do the first derivative test, just like I did. So even though I don't need to know all the other things, critical values, increasing, decreasing, I really kind of do need to know them to figure out where is the maximum, where is the relative minimum. Okay, so the first thing I'm going to do, find the derivative. Negative 3x squared plus 6x plus 45. Figure out where that's equal to 0. It's a trinomial. So for trinomials, first step is set it equal to 0. Done. Factor out a GCF. This one does have a GCF. I believe I can divide them all by negative 3. Oops, minus 15. First term needs to be positive. It is now, x squared. A, B, C, all that stuff. So depending on how you were taught how to factor in Math 2 and Math 3, there's different ways to factor this because this is a quadratic. So there's different ways to factor. Some teachers teach the X method. Multiply A times C, you get negative 15. Negative 2 at the bottom. Figure out the two numbers that multiply to be negative 15 and add to be negative 2. What is that? Negative 5 and positive 3. So you get x minus 5 and x plus 3. Okay. Zero product property says if I have a bunch of things multiplied, right? I have negative 3 times x minus 5 times x plus 3. And the answer is 0. That means one of them has to be 0. Well, I don't know which one is 0. So I'm going to set all of them equal to 0. Negative 3 equals 0. X minus 5 equals 0. X plus 3 equals 0. Well, negative 3 does not equal 0. In no world does negative 3 and 0 mean the same thing. Negative 3 means you owe $3. 0 means you don't owe anything. That's not true. So I'm not going to get an answer here because those aren't equal. The other one, I can add 5 to both sides, subtract 3 from both sides. So I get 5 and negative 3. Those are my critical values or numbers, whatever you want to call them. That's where the derivative is going to be 0. first derivative test. So negative 3 is over here, positive 5 is over there. Pick a number less than negative 3, pick a number in between negative 3 and 5, pick a number greater than 5, and see what type of number you get, positive or negative. That'll tell us if it's increasing or decreasing, if the function is increasing or decreasing. So first thing I'm going to do, let me plug in negative 4 to the derivative. Now, I don't care what the number is. I just want to know if is it going to give me a negative answer or a positive answer. So when you plug it in. So when I plug it into the derivative, I don't have to actually do all of my math. Just do your number. You know numbers. When you multiply and add, are you going to get a positive or am I going to get a negative? Well, let's see. This guy here would be a negative because negative 4 squared is 16 times negative 3 is negative, I believe, 48. Minus 24 plus 45. When I subtract those or add those, it's going to give me a negative number. That's going to be a negative. What number? I don't know. Negative 27, I think. So that means anything less than 3 is going to give a negative derivative. Decreasing. Pick a number in between negative 3 and 5. Anytime you can plug in 0, use 0, because 0 is nice, because everything cancels out with 0. Plug it into the derivative. So negative 3 times 0 squared is 0. 0 times 6 is 0. So I get positive 45. Positive. Increasing. Now, don't assume that after 5 it's going to be decreasing. More than likely, you're going to be right. 9 times out of 10, you're right. After 5, it will be decreasing. Look at the pattern, right? Decreasing, increasing. But once in a while, they'll throw in something. They'll throw in a increasing again. So that means the function might stop at 5, but then continue going up. So always check. Don't assume. Well, I'll plug in 6. So negative 3 times 6 squared plus 6 times 6 plus 45. Oops, negative 6, or positive 6, yeah. So 6 squared is 36. 36 times 3 is negative 100 and something. 36 times 3, 18, 108. 36 and 45. Well, 36 and 45 together make 81. That's not going to be big enough to make negative 108 negative or positive. So we're going to get a negative number. Be negative 27, I think it is. Okay. All right, so now we have enough data, enough information to figure out where is it decreasing. Where is a maximum or minimum? Well, where is a minimum going to be? When x equals negative 3, yeah, negative 3. Because it was decreasing before negative 3, and then it changed to increasing at negative 3. That makes a valley. That's what we're looking for, minimum. And then at 5, it changes from increasing to decreasing. So that would be a maximum, right? They didn't ask us about maximums, but Okay? So we would say relative minimum at x equals -3. They didn't ask us in this one, but they might ask us this question. They'll say, justify your answer. Justify means, how do you know that -3 is a relative minimum? Easy. Because f prime of x is less than 0. Or sorry, no. F prime of x switches from positive to negative at x equals 3. That's justification. How do I know that -3 is my answer? Because f prime, the derivative changes or switches from positive, or sorry, it should be the other way around. From negative to positive at x equals 3. Sometimes they'll ask you to justify. Free response questions, they will ask you to justify. Why? Your work is not justification. You have to explain your work. What does all of this mean? Well, because it's decreasing before -3 and increasing after -3, it has to be a minimum. Okay. All right. Okay, so let's look at number 3. So number 3 goes back to, we need critical numbers, we need increasing, decreasing, and I need all relative extrema. So what's the first thing I need to do? Find the derivative. So let's do h prime. Find h prime. Don't look up here. You guys have done this millions of times. Once you're done, look up here. What's the derivative going to be for h? Okay, so quotient rule. You just use the quotient rule like you guys have done lots and lots of times. Low d high minus high d low over low squared. So after I distributed, combined some like terms, I combined -x squared and positive 2x squared because they're like terms. I got x squared minus 4 on top and x squared plus 4 squared on the bottom. That's as far as I can go. Okay. What did I do after that? What was my next step? After I found the derivative, what did I do next? Set it equal to 0. Here's where not a problem, but here's where I have questions. How do I set it equal to 0? It's a fraction. How do I set it equal to 0? Well, if the top is equal to 0, that means that the whole thing is equal to 0, right? If the bottom is equal to 0, what does that mean? Undefined. So I'm just going to set the top equal to 0. And then set the bottom equal to 0. So I'll do the top first. I want to know where it's 0 and where it's undefined. That means the top is equal to 0 and the bottom is equal to 0. So I get x squared equals 4, square root, positive 2, negative 2. Okay, set the bottom equal to 0. Okay, take the square root of both sides. What's going to happen when I solve for x on this guy, on the bottom? Yeah, it's a fool's errand because you're not going to get an answer. Is there any number I can plug in for x that would give me 0? No. because everything I square is going to turn positive. Even 0. 0 squared is 0. Plus 4 is not going to equal 0. Negative 2 squared. Positive 4. Positive 4 plus 4 is 0. I'm not going to get an answer here. I'm going to get imaginary. And we don't deal with imaginary. We just deal with real numbers in this class. So this guy will not give me an answer. So my only critical values are positive 2 and negative 2. Critical values, critical numbers, whatever you want to call them. So positive 2 and negative 2. So plug in a number to the derivative. The derivative is up here. Plug in a number to the derivative less than negative 2. Plug in a number between 0 or negative 2 and 2. Plug in a number bigger than 2. What kind of number do you get, positive or negative? Well, when I plug in 0, I'm going to get negative 4 on top. I'm going to get negative 4 on top, and I'm going to get 16 on the bottom. That's a negative number. Negative 1/4. Okay, plug in a number bigger than 2. 3 squared minus 4. 3 squared plus 4 squared. I'm always going to get a positive on the bottom. Top, I'm going to get a positive. I don't even know what it is, but it's going to be positive. Number less than negative 2. Again, you're going to get a positive number. It's going to be a positive number. Okay, I'm going a little fast because we're running low on time, but you can essentially get the idea. So increasing before negative 2, decreasing between negative 2 and 2, increasing afterwards. Okay, so write that down, and we're done. So increasing from negative infinity to negative 2, or 2 to positive infinity, decreasing from negative 2 to positive 2. I'm going to have a relative max at negative 2. I'm going to have a relative min at x equals 2. Okay. All right. The only difference tomorrow is now we found relative. Now we're going to find absolute. Absolute's a little bit different, but very much the same. Okay, and then we'll be done.